Hi guys, so today we will talk about IR spectroscopy. A lot of times, we chemists face a very big challenge, and that is we cannot see molecules. So we might do some chemical reaction, get a product, and we need some way to be sure that what we got is what we think it is. So this technique is under the term that called spectroscopy. Spectroscopy is the study of interaction of lights and matter. So there are a lot of types of spectroscopy to gather the data about the structure of a molecule that might be. So now we will look at IR spectroscopy. IR stands for infrared. So with IR, the bond can do something like symmetric stretch and also asymmetric stretch. So the point is we have different kind of vibrational motions and occur at particular energies or at very specific wavelength, and this will affected by the functional group. So that's when IR comes in. So as you guys can see from here, IR light will interact with some molecules of the compound in the sample, and then some molecules will absorb the infrared light, some will pass through and some will not, and the detector will give the information that we get, and the information we can use to figure out about the structure of the molecule. The first step for Nujol mold is small amounts of sample is ground to fine powder using mortar and pestle, and then we add few drops of Nujol. Then two mix together to create the paste, and then the sample will transfer to potassium bromide disc. Remember, this disc is very sensitive to water. And then take care properly the mixture by using spatula. And then two discs then press together to create film. The plate holders are used to support the disc, and then the sample is ready to go into the spectrometer. The next way for sample preparation is solution. Let's begin with small amount of sample is added into the sample vial, and then solvent will added to prepare approximately 5% of concentration. And then the solution cell that used to contain sample in spectrometer, and always remember the solution cell must be placed in dry environment as it very sensitive towards water. Next, transfer the solution into the cell, and then use small plastic plug to close to make sure no sample is escapes.
The IR spectrum will show the information from 600 until 3400. So first, from the range 600 until 1400, we can see the information about C single bond C, C single bond N, and C single bond O. The C single bond O will show the strong peak. Next is from 1600 until 1800. The information from this range we can see is C double bond C, C double bond N, and C double bond O. The C double bond O is about 1715 cm-1. So under this range, we can see the information about either it is ketone, aldehyde, ester, carboxylic acid, or amide. Next, at the range 3000, we can get information when we divide it into two. If it is before 3000, we can see C single bond H sp3. Well, if it's more than 3000, we can see C single bond H sp2 and C single bond H sp. Last, from the range 3200, we can see the information about OH, which will show strong and broad peak, or NH, which will show weak and medium peak. If the information is NH, and if it is 2 peak, it will show the primary amine, while if it is 1 peak only, it will show the secondary amine. For the benzene, it will show the information at below than 1600 cm-1. So let's do the question. For the first question, we can see there is a strong peak at 1718, which will it is near to 1715, which is ketone. It is C double bond O. Next is before 3000, it is show the C single bond H sp3. So for the next question, there is a strong peak which at C single bond C. Next is a strong peak before 3000, which it show it is C single bond H sp3. And there is a peak, a strong and broad peak, where it is 3339, which is it is a OH.
Assalamualaikum. My name is Nur Hamiza binti Rahadi and my matric number is 194167. So, what was the question? Okay, I'm taking Bachelor Science in Chemistry.
What do you understand about IR?
What I understand about the IR is based on the spectrum, and then I refer to the table, so I got to know the functional group that exists in the compound. So the most obvious that I can guess the functional group based on the spectrum is such as hydroxy groups, the amide or NH groups, and then the sp3 or sp2 or sp.
What I understand about IR is that you use IR to detect the functional group of a compound.
So how I'm interpreting the data is like based on the spectrum. The first thing that I observe is whether the most broad or intense spectrum whether are above 3000 or lower. So if it is lower than 3000, based on the table we can see that it is whether CH aldehyde or CHSP3. So if the spectrum is above than 3000, so you can see that it is whether sp2 CHSP2 or CHSP. And then the intense peak between 1600 something is whether what I call that C double or carbonate kill.
So when you do the IR, you will get the IR spectrum, right? So for IR, we have a table, IR for the functional group, which wavelength represent which functional group. So from the spectrum, you can easily detect which wavelength represent which functional group, like that.